Next, we're going to practice using the DMD scan table to look at some velocity signatures and put it in the context of some velocity signatures from this outbreak in the test case. So let's start on the WFO scale, and in the frames, let's go with a 12-frame loop. And under the scan menu, we're going to select, go all the way down to the bottom, and under KCRI, we're going to select the DMD icons and table. When that pops up, we are going to go, we've loaded this for KCRI, so we're going to go to KCRI menu, and we are going to select 0.5 ZSRM8. So we can always have some base data to compare to, so we can put these algorithms into some sort of reference. So with the DMD table, just like the storm cell table, if you left click on one of the values in the ident column, then it will zoom in to those features. One of the things we realize right away with the DMD is there's tons of circles that are being tracked by the DMD, and the philosophy behind this algorithm is that it tracks all strength of features, and then it lets the user decide what's significant, because there may be times where you've got tornadic circulations in landfall and hurricanes where maybe the rotational velocities are only 20 to 25 knots, and then you may have planes outbreaks, or big outbreaks over the U.S. situations where you've got rotational velocities that are in the strong 50 knot category. So again, the algorithm is designed to track everything and lets you filter out a lot. With this kind of situation, we see obviously that there's a lot of shear in this radar display. So let's click on the dot key on the keypad to toggle over to SRM. And let's go ahead and step through the loop as it is. We'll zoom out a little bit so we can see the full display. Let's look at how the algorithm has done in terms of tracking. We see there's this big monster supercell down here, which it actually drops some of these. It does well for a while and then drops some of those detections. And then we see lots of other groups of detections that look like they're kind of translating along with the what looks to be an Rmax in here, where there's probably some noisy velocities. So one of the first things you do if you're going to use the DMD table and algorithm is you can go in the configurations and go under the D2D display with the left mouse click. And the yellow triangle controls the display filter for what 3D strength rank you want to see. So it's set to 2 right now. So let's go ahead and change this to a 3D strength rank of 4 and click apply. And we see that it filters out a lot of weaker detections, and if we're just interested in the strong ones, then this is going to give us something that's a little bit easier to interrogate. Now the red triangle is where you can define what is a mesocyclone. It's pretty much an arbitrary definition that you'll see in the table. It's set at 5 right now, so anything a 3D strength rank of 5 or greater is called a mesocyclone. Anything less than that is called a circ for circulation. So now we have this filtered display, and let's go to the last frame here of the sequence. I'm hitting the right arrow to go to 2338. And we can sort the contents of the table just like the storm cells table with a left click on the column ID. So we're going to rank by 3D strength rank, and let's left click on ident 168. We see there's detection in here. We can bring these out a little bit more by right clicking on the DMD text legend, changing the magnification to 2 so we can read that a little bit more. So we have these in the display. We can sample them out as well. So if you don't want to use the table and you want to use the display, you can see there's a 3D strength rank of 8 is what's in the display there, and the low-level rotational velocity is 19 knots. But that display, I don't think it has much time continuity. So anything that doesn't have a lot of time continuity is going to be a little bit suspect to begin with. So let's click on the next detection. Is 168. Left click on 213. We see that's in the noisy data right at that first trip. We see it's broken up this other storm into multiple detections. But there's a lot of detections to kind of choose from and to be able to look at and identify But let's go ahead and pan our display down for this supercell down here, and we'll find one of these detections where, let's go backwards in time from the end of the loop, and we'll see where did it have this mesocyclone that it's tracking where it looked like it did a pretty good job. So looks like there's this window right in here around 2250 where the DMD had been tracking something kind of persistently, and that's with ID number 29. So we can go up to our table here and we can look at our 3D strength rank. The top ones in here, there's number 29. One of the things you can do with the DMD table, besides left clicking on 29 to recenter on it, if you right click on 29, it's going to give you the Dmd Trend Graph. And so first challenge is finding a DMD identification and an ID that it has been able to track for a while. If you do have a persistent track, then it can tell you some useful information, at least what the algorithm's been seeing for a while. Here's the 3D strength rank, where over the last half an hour we see the values have been going from a 4 and 3 values up to 5 to 7, and so we see that there's been persistent rotation that's been characterized as moderate to strong with the 3D strength rank. The Mesocyclone strength index, it's an integrated quantity, is very similar to 3D strength rank, and they both kind of say the same general trend of increasing in strength over time. The low-level diameter, I wouldn't put too much faith in the diameter because that's a much harder thing to assess for the algorithms. But it is there for, if it looks like it's doing a good job, then you could use that. But certainly rotational velocity, 3D strength rank, those are the kind of simple parameters that are worth starting to look at when you're first getting used to the DMD. So we have a 3D strength rank of 6, and we see that the TVS algorithm has fired with this close to this supercell, and it's associated a TVS with it. If we go over to the low-level rotational velocity, it's 45 knots. We can zoom into this and double-check that for ourselves. We've got our mesocyclone here, which our radar is over to the right. We see this strong storm relative inflow moving in from the southeast, and then there's some inbounds on this side in the rear flank downdraft. So we see that there's a nice balanced peak inbound and outbound velocity that's straddling the shear line, and that's 55 knot outbounds and a 24 knot inbounds. So 24, it's what, 55 minus 24 is going to be 79, close to 80. 80 knots divided by 2 is 40, so this should be somewhere around a 40 knot rotational velocity, and it's found 45 in all the different values that it's been detecting, so it's close. The other thing we can do is, besides left clicking on a box value, we can right click on it, and that's going to launch the time height trends. Now, time height trends are a really effective way to look at the evolution of rotation at different heights and with time. What we have here is a series of overlays that you can turn on. There's volume scan polls to tell you each of these is a 2D feature that's been detected at a different elevation angle. So this is for one volume scan, different 2D features. There's the elevation angle that they were detected on, so you can use this to get some sense for above 1.8 degrees, it's losing the vertical continuity, which I doubt that the mesos are shallow in this case. It's probably just a severely tilted or mesocyclone or something else that's causing the algorithms to have a hard time with. And then there's a diameter overlay you could augment the rotational velocities with, but this gives you some sense for the evolution of rotational velocity when you right click on the LLVR. And again, the general strength, 20 to 30 knot rotational velocities at most ranges are going to be on the weak side, and then 30 to 40 is going to be in the moderate category. And once you start getting above 40 to 45 and 50, that's where you're seeing really strong rotation developing over the last, looks like the last 10 to 15 minutes, it's really increased quite a bit. So if you're doing your base data analysis with your all tilts, you should be seeing this. But if you needed some augmenting of your analysis of what the rotational velocities are, you could use the algorithm when it looks like it has continuity. The trick with the DMD is going to be days when it performs well and are tracking features that look persistent, and then being able to use it to leverage that information when it does exist. The problem is many times the DMD can be noisy and have a lot of problems with it. And if you're spending more time trying to find out why there's bad algorithm detection information in there, that could actually hurt your warning decision making. So, because of this, our philosophy to start out with is really focus more on the base data. You're going to get a lot out of expertise growing when you look at the patterns that evolve with severe convective weather, and you get used to looking at the base data primarily and using the algorithms as a safety net. And insofar as the algorithms can provide you information, simple information that doesn't distract you from kind of keeping in touch with your storm, then you can use the algorithms overlays. You can use the DMD from the radar table, or from the radar menus, or you could use a DMD from the scan DMD table, depending on if you want the overhead of the table in there, or if you just want a simple algorithm overlay that you can sample. So you can sample all these algorithm attributes. Just know that there's a lot of noise in the algorithms, and so use it judiciously. It's a safety net, and it's a safety net with holes, though. So that's kind of a summary of the DMD table and the scan DMD table. So at this point, we're going to give you the option of using the storm cells table and the DMD table in your simulations in the workshop, but we're really wanting you to focus primarily on your base data analysis. And then if you're interested in using these and they're used at your office, then you might try them out, but use them to augment your base data analysis is kind of the bottom line for these things.